Peace be upon you all and welcome to the channel. We'll be continuing from our last video and we'll start with the creation of the standard curve. So the last time we stopped, we measured the distance for each band in every lane. And then I wrote the distances here. But please make sure that if you're using one unit, to keep it consistent, so do not use centimeters on one band and millimeters on another band, because if you use different numbers on your standard curve, then you will not be able to obtain the correct curve for the calculations. So if you remember from last time, we wrote down the base pairs for each lane, band, in the ladder, and here we have the distances for the ladders. So we will create an X and Y table on Excel. So let's open this up. So we'll call the X-axis DNA size, and the Y-axis will be distance traveled. The reason that the distance is is the dependent variable is because the bigger the band size, the shorter it will travel, and the smaller the band size, the longer it will travel, which means that the band size influences the distance traveled, hence why DNA size is the X or the independent variable, and distance traveled is the dependent or the Y variable. So let's start with the band size, the ladder, sorry. So I'll write down the units as well. Just elongate the cell here, and I'll probably need to elongate it as well. So I'm using centimeters, but you can use millimeters if you want. So 4,500, then 4,000, and we can simply drag and let Excel continue for us until we reach 500. Then we'll put the corresponding distance for each band. So this was 4.2, 4.9. This was, I forgot, I'll have to check. 5.7, 5.7, 6.5, and 7.7.5, 7.5, 8.7, 10.1. This was 12. 12. 12, 14.7, and lastly 19.1 centimeters. So now we have our table with band sizes and corresponding distance traveled by each band. So we'll simply make a curve. So insert, scatter, and scatter with only markers. Now, as you can see here, you'll find that the relationship between the x-axis and the y-axis is an exponential one. And I feel that some people take a different route from what I will use. So I find it easier, instead of using the exponential curve, you transform this into a linear curve so that it will be easier for you to manipulate and extrapolate data from. Of course, you're free to use whichever method you find suitable for you, as long as you get the correct results. So what I do is I will transform this into a logarithmic curve. So I highlight the y-axis like so, and then I hate it when that happens. Yeah, format axis, and then choose logarithmic scale, then close. Then you don't have to do this, but I prefer to add the major and minor guidelines just to remind myself that this is a logarithmic curve. And then you add the trend line which is logarithmic, and then make sure you display the equation on the chart, because this equation is technically the standard curve. This is what we will use for extrapolation. So as you can see here, we have the equation right here. You can extrapolate the data on the graph, but I find that it will be a bit too inconvenient. Using the equation is much easier and much faster if you're adept with Excel, unlike me. Sadly, I'll have to calculate this with a calculator because I do not know how to rearrange equations in Excel. So let's write it down. Where was that layer for it? This one, and we'll zoom out. Okay, so let's write the equation. Was y, remember y is the distance traveled. Distance traveled equals negative 6.4, I think it was 77. Where's the cursor? 7 ln x, which is the DNA size. What was after that? Plus 59,357 plus 59.357. Just take a look back to confirm. 375, yeah, I thought as much. Just erase those two, pen, and then 375. So to rearrange this equation is quite simple. You can do it in Excel, as I said before, and calculate the x values from the given y values much faster than the method I'm about to use. So to rearrange this equation so that x is the subject of the equation, we'll just move this to the other side to get rid of the negative. So we'll say 6.477 ln x plus y equals 59.37. And now, because we want to isolate x, we'll have to remove everything to the other side. So we'll take the y to the other side, and if you move a number or a variable in an addition operation, it moves to and becomes the opposite. So it will be subtraction. So it will be 6.477 ln x equals 59.375 minus y. Just so that people know what moved, so I'll just move this here. Yeah. Then we isolate the ln x, so we'll move the 6.477 to the other side, and since it's in the multiplication operation, it goes and becomes inverted, so becomes the opposite. So the opposite of multiplication is division. So it will be ln x equals 59.375 minus y over 6.477. Now finally, we need to isolate x itself, so we'll take the ln, push it to the other side. Now the opposite of ln, or the natural logarithm, is the exponential, which is short for e. Let me see if I have enough space. I don't have enough space. Okay, I'll create another layer then and use that. I'll just have to memorize the numbers. Okay, so I'll just write the title in case people didn't watch the video from beginning. They know that we're still on the standard curve equation. So x equals e, and then to the power of 59.375 minus y over 6.4777. I'll just confirm it. Yep, 6.477. So this is the standard curve equation we will be using to calculate the DNA sizes. So the next step would be, oops, sorry. Where is the, yeah, here we go. So the next step would be using the equation, placing these distances as y's to calculate the x. So for example, let's take 6.5 here. So we will say, example, x equals e 59.375 minus, we said 6.5, so that's the y, over 6.477 to get our value. And we'll repeat, or actually I will repeat these steps because I'm pretty sure people will probably use Excel for that. Oh, wrong layer. Yeah. So basically what I will do and start the next video will be calculating the band sizes for each of these bands using the standard curve with the distance traveled after the measurement. So I will end the video here. Thank you very much for your time. Be safe and take care.